Wow, wait, I'm assuming you're an aspiring programmer. Well, I have to explain something to you really quick. You know what it is? It's about Git and GitHub. Yeah, so, you're gonna have to use this. There's no getting out of it. You're not gonna be able to just like store your text files on your computer and call it a day. No, you need to understand this because it makes things so much easier for you and your team and whoever you're collaborating with, and you'll be able to store your code. And yeah, anyway, so we're gonna be explaining Git and also GitHub. They're not the same thing. Git explanation speedrun. Let's go. All right, let's try to explain this fast. So what exactly is Git? Git, not GitHub, but just Git, what GitHub gets its name from, is a version control system that is used to track changes in code, manage different versions, and collaborate on any sort of programming projects. It's distributed, which allows multiple people to work on the same project without any conflicts if everything is organized. More on this when I explain branches and merging conflicts. And of course, for us to get to that, we have to explain some key concepts. So the biggest thing that I want to explain are commits. What are commits? They're small frequent saves of your work. Each commit includes a message that describes the changes. You can think of them as like checkpoints that let you track progress and revert changes if needed. Just like a video game, really. When you're making a commit, you're either pushing a commit. After committing locally on your computer, you push the changes to a remote repository, which is just where your code is stored, so that others can see it and access it. Or you're pulling, where you're just taking the code off of the repository and you're able to see it. You're downloading it onto your client, if it's VS Code or wherever you're coding at. And you gotta keep in mind, you wanna make commits frequently. Whenever you make a noticeable change, really. If your work isn't finished or may not work yet, make a branch and commit to that branch. Save your work, please. We've had so many problems doing this in the past. Now, what I'm going to explain are branches. So, I talked about branches at the beginning of this video, but what a branch is pretty much your program is primarily held on the main branch, which is the main code base for everything that you do. This is the branch, by the way. You can create other branches for use as isolated environments for changes or new features. So like, the timeline thing from like the multiverse from Marvel? Yeah, the sacred timeline, then you have like all the other branch off timelines, and all the other Earths and universes and stuff. You can experiment without affecting or breaking any of your existing code on the main branch. So you can take it, put it onto your new little testing ground branch, and then if everything's working, you can merge the new changes onto the main branch. If not, you can just scrap the main branch, like how Paradox and Deadpool is just going to cut off Deadpool's timeline, Releases. So a release is pretty much a version of the project at a specific point, usually for major updates, but also, you can do it for smaller patches and that sort of thing. To title these, you follow semantic versioning. So that could be like 1.0.0, 1.2.3, 3.0, or like 4.7.5. If you've played Minecraft before and you've seen the numbers for updates and patches, you likely know how the system works. And now you have pull requests. So once changes on your little testing pocket dimension branch, separate from the main branch, have been tested and, they actually work, a pull request is made to merge them into the main branch. Now you want to make sure that, your code's working, because you don't want to merge code that doesn't work onto your main branch. That would just cause problems. Now you have a program that has bad code, and you have to go back and revert it back to what it was before. So once you do that, make sure it works, do your pull request. Pull requests make the whole collaboration part of Git into a real thing, as it allows review before merging. A pull request is a request to merge the code in. So when you do it on GitHub, you get a little screen showing, like the changes and everything. It'll show you, do you want to make the pull request? And then once the request has been made, you can merge it into the branch. But you can always review it before. It's a request. You'll often see this on big projects where, a lot of people are working on the source code at once. If one random person decides that something is messed up inside this code, they can write up a change and submit a pull request to whoever is maintaining the repository or whoever has permissions to merge stuff. And then they can merge that change if they want to, if it fits the program, if everything works. And now for our additional stuff part. Here's a few additional things that you might need to know in order to use Git. Some of it a bit more straightforward than others, but you'll probably need it. Cloning. So what does cloning do? It downloads a copy of the project onto your local machine to work on it. It has all the history and everything that from the repository, and is pretty much a full copy of the repository made available to you locally. Sometimes you might have to merge conflicts. So if two people have the same file downloaded from a repository, and these files may have a bug inside of it. So of course, naturally, whoever's programming and trying to fix and debug this code, they're going to try to solve that. But there's a good chance that these two people, they're both going to have different solutions for whatever the problem is. So when they both make the commits are going to be different. The whole file, that part of the file is going to be different. So it's a different file. Well, then how do you solve this? You can't have like these two conflicting, this mess going on with your code. You have to pick one of them. So that's where you have to merge conflicts. Git is going to ask you manually which changes you want to keep. Think of it as like the red pill and the blue pill. You're going to have to pick which of these changes you want to keep. Maybe both of them work, but maybe one's more efficient than the other. Maybe one has less lines of code than the other. Maybe one's just, a solution that brings more features or more, stability and usability to the app for the end user. It's up to you. Staging area. Staging area is just a middle step where changes are being prepped before being committed. This lets you decide what goes into the next commit. And then finally, what may be the most important one for somebody who's just now getting into Git is Git versus GitHub. These are two different things, okay? They are not the same thing. Please do not get Git and GitHub confused, okay? Git is the version control system, while GitHub is a platform for hosting repositories and facilitating collaboration. Git is what underlies GitHub. GitHub is built upon Git. So you have Git, which is the bottom thing, and my computer just shut down. And you have GitHub, which is the little shell. Git is primarily accessed by command line, commands and the terminal and all that. It's not very friendly for somebody who's just getting into programming or, is just trying to understand, just trying to store their code and all that. That's why GitHub makes it so much easier, because it gives you a graphical interface to be able to use Git. And also a lot of other quality of life features, because, GitHub is GitHub. You have code spaces and all this other cool, fantastic stuff, accounts, cool profile pics, that sort of thing. GitHub uses Git to host and provide the services for all the glorious source code repositories you see all over the internet for all of your favorite open source software. And also a lot of companies also use Git, GitHub, like private repositories, to host the code for the closed source apps. Everybody uses Git in the programming world, technology space, and it is something that you need to understand if you're an aspiring programmer just like me, or any of your friends, or you get the point. Anyway, my computer is at like 4%. I hope that this little tutorial helped you. It was really just something that I made for hopefully the people on my robotics team to be able to see, and get something out of, because Git is very confusing, and GitHub, even though it's a graphical interface, is still confusing to look at for a beginner. So yeah, I'll see you later. My computer is at 3%. This is why, like, gaming laptops are not it. Like, seriously. Seriously, like, gaming laptops are not it. This thing is at 3%. I'm also currently in a hotel room. I just moved. Bye. Alright, I just finished the video. It's time to eat this dessert. This cookie I got from a restaurant like 4 days ago. Yeah, alright. 10. This cookie is so stale. Oh my.